So we've worked with parallelograms a lot. We know a lot of things about parallelograms. Can you think of anything you know about a parallelogram?
They don't touch.
What don't touch?
They're parallel.
The parallel?
They eat. They're parallel. So what we like, it's too thick.
Now, y'all have better math vocabulary than that. I know you do. How many, there's something congruent, but the parallel, say it again? It does have four sides. The quadrilateral, all parallelograms are quadrilaterals. What else do we know? Even
Perpendicular.
definitely not perpendicular. Shape shifting. Say that again? Not necessarily. It has a base and a height.
Two separate pairs.
Two separate pairs of what?
Lines. Two separate pairs of
Parallel
sides.
Right. It's got four sides. The opposite sides are parallel to one another, right? So this one's parallel to this one. This one's parallel to this one, right? Is that a polygon? The parallelogram a polygon? You know what a polygon is?
Yeah. No. Yeah.
It's straight sides and it's closed. A triangle is a polygon. Three straight sides that are closed. Is a circle a polygon?
No.
A circle's not a polygon. Is a semicircle a polygon?
No.
No. A parallelogram is a polygon. Triangle is a polygon. Is a square a polygon? Yes. Okay. So for today, really what we need to know is opposite sides are parallel and opposite sides are congruent, right? So if we're finding the area of anything, the first thing to remind ourselves is it's always, our answer is always going to be a square unit of measure. Lennon, you're writing what I uncovered, bud. Yeah, you're writing what I uncovered. The formula for the area of a parallelogram is base times height. Now there is a diagram there of a parallelogram. Are those dotted lines, are they part of the parallelogram? No, they're just showing the distance from one side to another side, right? Normally they only show it in one spot. So sometimes they show it on the outside of the parallelogram. And we have to know that if they show it on the outside of the parallelogram or the inside of the parallelogram, it's still the same height. So that is the same distance, I should say, distance from here to here. So we pick a base, and then we find the height between that base and its opposite side. That's what the height is. The base and height must be perpendicular. Remember, perpendicular means opposite reciprocal side. That means they form a right angle. Why do they have to be perpendicular? Anybody remember? I remember talking about measuring from the top of my head to the ceiling. And if I did not go straight up from there, which would be perpendicular to a line across my head, right? Those would be perpendicular. If I want the actual distance from the top of my head to the ceiling, the only way to do it. If I do it at an angle, is that going to be the real distance from the top of my head to the ceiling? No, right? Now, if a particular point someplace else, then I have to stay here. But if we really want to know the difference in my height and the height of the ceiling, it's got to go up perpendicularly, right? So that's why these are perpendicular. We want to know the distance between the base, the two pairs of parallel sides, that's the height. We need to designate a base. Once you designate a base, and they designate it for us usually with their diagram. So once we know what the base and height is, we plug it in and then simplify. So we identify the base and the height, and then we plug in. So what is the base in example 1?
15.
15. Now, 15, it does not indicate it's perpendicular to this side that's labeled 15. How do we know the base is 15? Yeah, so these two sides are congruent and parallel, right? But the congruent part's really what we want right now. So this distance from this side to this side, they've shown us that they technically designated this side as the base. So our base is 15, and what is the length between this side and this side? Well, that's our height, and what is the height of example 1? 9. So now we just plug into that formula. The area equals the base times the height. And that is 135 inches squared. That's the answer. That's all. Now, normally, they get harder as they go, right? So you would think today they're going to get harder as they go? Well, you would be wrong today. They are not. This is straight what we're doing. All assignments, all right? So normally I make you get out pencil and paper for this. Like, you don't even have to do pencil and paper until you get your pass it in. Corey?
So why do we put it on?
They're giving you the other length of that side. In these cases, they want to make sure that you know the difference, right? We can't use this 10 as a base because we don't know the distance between its opposite sides. Could we use that? Sure, we could. If they gave us that, if they gave us the distance between these two sides and indicated that there's a right angle there, we could use 10 for the base if we knew what the height is. Well, we don't know what that is, but you would get the same area, right? It gives you the same area. Okay. So sometimes they give you that height on the outside, sometimes they give you that height on the inside. What's the base of this triangle, Justine? 12, yeah. So this line, dotted line, that's indicating the height or the length from this side to this side, well, that would be the same as if they drew it in here. It doesn't matter. Right? Those are the same thing. It would still be 11. So the base is 12, and the height is 11. So once we've identified the base and height, we just plug in. I think it's 132 centimeters squared. Is that right? Yeah. Okay. So is the dotted line part of the parallelogram? It is not. The parallelogram has 4 sides, right? 2 sides parallel, opposite sides are parallel and congruent, opposite sides are parallel and congruent. The height is not a visible part of that parallelogram. What is the base of example 3, Sharad?
14.
Perfect. What's the height in example 14, MJF?
I'm sorry.
So what is the distance between the base and its opposite side? Yes. So the area, once we've identified our base and height, we plug it into the formula. So that's 14 times 6, or 84 square feet. So we can read that as feet squared or square feet. It means the same thing. We're going to finish our assignment, and then you can scan it in your notes. It is published. You can also, we're not done yet, I know, but I was waiting. I was trying to fill in some time where everybody's finished writing. All right, base and height. No back. You can actually use the back of these notes for your work when you're working on your path. You don't really need a new paper for the assignment. I thought at some point they were going to go give you the area and make you find the base or height, but they do not do that in this assignment. So what's the base, Yuri, of this example 4? Not 12. So this dotted line is perpendicular to this side, right, Yuri? This tells us it's perpendicular, creates that right angle. So whatever side that the dotted line is perpendicular to, that's the base. That makes sense, Dominic? So the base is actually 11. So then what is the height, Yuri? Yeah. So once we've identified the base and height, plug into the formula. Easy peasy, pumpkin squeezy. 99 square yards.
I do that.
Okay.
Okay. D equals 13.
Good.
H equals 11.
Perfect. So this side, now they didn't show this here. We should know. Well, I think it was a mistake. I think it's a typo on there, but they should have indicated there's a right angle there. This is the base. This is the height. Plug into the formula.
143.
Nice. If I write 143, will I get the right answer?
No.
No. What do I put?
No.
The unit. Is that right?
No.
No. It's going to be squared. Good job. Okay, we're not going to scan and submit yet. You can scan and submit as soon as you finish the assignment. What time period?
How many questions are there?
I don't know, but it's fast. Sharad, you're not talking to anybody behind you, right, buddy? Stand that way, Sharad. Stand that way, bud. I don't think that's true, Sharad. I watched you turn